Okay, 5-2, we're going to look at another sort of operation of functions. We don't include it with 5-1 because it's something that's probably going to be pretty much completely new to you, and it's maybe a little bit more complicated than the operations that you would have done in 5-1. So the addition, subtraction, multiplication, division. What we call this is a composition of functions. And so our objective is that we're going to perform compositions of functions and then apply them. The composition function, what you'll notice is it has this little dot that is open. So instead of it being filled in, which means multiplication, this one is not going to be filled in. And essentially what it does is it takes g of x, so it takes the output of the g function, becomes the input of the f function. So you kind of always want to think about it as you're working from the inside out. You always kind of want to tackle the inside function and then apply it to the outside function. So the second function, the g, that's always the one that's inside the parentheses, and then the f function, again, is what you would have started with. So I feel like it was going to make more sense once you just do it. I will also just make a note here that there will probably be another little note sheet that will be posted in Google Classroom to help you on the assignment if you get stuck, because it's kind of impossible to go through every single type of composition you might see. I'll put a couple more examples again in like a document that I'll write out that might help you if you get a little stuck later on. Okay, but let's just get started. So example 1, it says evaluating a composition of functions. So it says the functions r and s are defined as follows. R of x is equal to negative x plus 2. S of x is equal to 2x squared plus 1. Find the value of r of s of 2. So what we're looking at there, okay, you want to start from the inside out. So your inner function is the s function. The outer function is the r function. So what I want to do is start by finding that inner function value. So we want to find what is s of 2. And again, that is something that we've been doing really all of this quarter so far, or all of last quarter. We're taking the number and we're substituting it back into the function. So we're taking the 2 and we're going to substitute it in for x in this function. So I say 2 times a 2 to the second power plus 1. And if I solve that out, I'm going to get 2 times 2, which is 4, 4 times 2, which is 8, 8 plus 1, which is 9. Okay? So now, what I want to do, I found the output of s. This output of s is now going to become my input of r. So, again, r of s of 2, if s of 2 is 9, because that's what we solved it for down here, so s of 2 is equal to 9, if I substitute in a 9 for s of 2, now I'm just looking for r of 9. And this time, I'm going to go take the x value and substitute it into that top function r. So I get r of 9 equals a negative 9 plus 2. If you want to put parentheses around the 9, you can. So it'd be negative 9 plus 2. And then if I take negative 9 plus 2, I get negative 7. So r of s of 2 is equal to negative 7. Okay, so start by finding the inner part. Find that function value first. That function value goes in as the input of the outer function. Okay, so there will be some like that where, again, they may not all look exactly like this, but take whatever function is in the inside, tackle that one first. Okay. Letter B. This one you can see we kind of have a function, a square root function, which we really haven't done much with in this course yet. But again, it's just giving us two functions. It says the functions u and w are defined as follows. So u of x is equal to x squared plus 9. W of x is equal to the square root of x plus 8. And again, we want to find two things. We want to find u of w to the 8 and w of u to the 8. So the way I look at these, if you put it back into this form, because this is the form it's given to us, the outer function here is u, the inner function is w, and the value is 8. So this would equal u of w8, and the bottom one would be w of u of 8. And so remember, for both of these, what you want to start with is start by finding the inner part of the function. So if I know that w to the x is a square root of x plus 8, okay, because that's what this function is, if I want to find w of 8, which is what this problem is asking me to do, okay, the inner part asks for w to the 8, I'm going to put an 8 in for x. So I get 8 plus 8, which is the square root of 16. Okay, so w to the 8, square root of 16, we are just going to go with a 4. Now last chapter, when we took the square root, remember we were always getting a plus or a minus? That was when you were solving for x. Here, you're just taking the square root of 16, so that's why we're always just going to use the positive root right here. So we're just going to use a 4. So u of x now, okay, because now I'm going to the outer function. We tackled the inner function, which was the w. So w of 8 is equal to 4. We figured that out. Now we want to tackle the u function. The u function is x squared plus 9. And what we're doing is we're substituting in w to the 8 for x. Okay, so again, if you're looking for u of w to the 8, you're substituting w to the 8 in for x. So you have a w to the 8, or w of the 8 to the second power plus 9. Now, we found what that number was. W to the 8, we actually have a value for. It's u of 4. So I'm going to have a 4 to the second power plus 9. 4 squared is 16. We're going to have a 16 plus 9, which is a 25. So u of w to the 8, or w of the 8, is equal to 25. Okay. Now we want w of u of 8. So we want to find u of 8, and we're going to substitute that back into the w function. So again, you're going to start, you want to find u of 8, okay? So if we want to find u of 8, I want to use the u function right here, okay? And u of 8 is going to be putting an 8 in for x, so I get 8 to the second power plus 9. 8 times 8 is 64, so you get 64 plus 9, which gives me a 73. Okay, so u of 8 is equal to 73. So what I want to find then is w of 73. Okay, so I want to find w of u of 8, but if I know that u of 8 is equal to 73, what I really want to find is w of 73. And I'm going to use the w function right here. I'm going to put a square root. X is 73 plus 8. 73 plus 8 gives me an 81. So you get a square root of 81, which is a 9. So w of u of 8 is equal to a 9. Okay, so the output of one function becomes the input of the second function, is what it comes down to. Okay. So there will be quite a few questions that are just going to ask you about that. The last couple on the ALEKS are going to be like these next ones. So example number 2, we're still going to be doing a composition of functions, but it's also going to ask you about the domain. And it's been a little bit since we've really discussed the domain in detail, but remember that your domain is going to be the x values that are defined in the function, okay? So letter A, it says for the real value functions, f of x equals x squared minus 3, and g of x equals the square root of x minus 4, find the composition f of g and specify its domain using interval notation. So f of g of x, just as a reminder, f of g of x is what we're talking about here. So if we follow, okay, we're going to be taking g of x and we're substituting it into the f function. We haven't quite done one like this, okay, because everything that we've done, we've actually been able to find a numerical value, and then we plug that numerical value into the function to get a final answer. Our final answer on this problem is going to still be in terms of x. So what I think is kind of helpful sometimes, if I just start out with f of x. So f of x was given to me as x squared minus 3. Then I substitute, I wanted g of x as my x value. So again, when we want f of g of x, a g of x is going in for an x. So instead of an x squared, we'd have a g of x squared minus 3. Okay, so the x, g of x got substituted in for x. Now g of x, we know g of x is over here. G of x is equal to x minus 4. Or sorry, the square root of x minus 4. So what I can do then is substitute g of x as the square root of x minus 4, because again, that's what it tells me g of x is equal to. And then we can just solve it. Now, if you have a square root and you square it, all that's going to do is cancel those two things out. So the squared goes away and the root part goes away. And whatever is underneath the radical is what stays. So we're going to say x minus 4 minus 3. And if you solve this, x minus 4 minus 3 would give me an x minus a 7. Okay, so this is what f of g of x is equal to. Now, there's something that we also need to look at. So it's also going to ask you, what is the domain of this function that we've created here? You're going to want to go back to what it first looked like. So at this step right here, and when we have a square root right here, we're talking about real values. So we don't want the number under the radical to ever be a negative for this problem. So you want to take what's under the radical, the x minus 4, and you want to set that as an inequality is greater than or equal to 0. Because again, you want to make sure the number under the radical is not negative. So whatever x is, you want to make sure whatever number is in there, it doesn't make the number under the radical a negative. So if we say that we want x minus 4 to be greater than or equal to 0, we're saying we want the bottom or the inside of this root to be positive. And if we solve this, add the 4, we get that x is greater than or equal to 4. Okay, and so it says we want to specify this domain using interval notation. Interval notation was, again, where you use parentheses for less than or greater than. You use brackets when they're included, and you use a U if there's a gap. Here, we're just going to be starting our x values at 4, and they're going to be getting bigger. So 4 is included, so we put a bracket, and it's going to go to infinity because the numbers are just going to keep getting bigger. And then you put a parenthesis with infinity always. So this is its domain. Okay. You would write that. My guess is this is probably going to be the more difficult part of these problems, just trying to remember. However, it's either going to be that you want it to be positive, so greater than or equal to 0, or, as you'll see on the next one, you just want it to not equal 0. Okay. So the last one we're going to go through together in the video, and then again, like I said, there will probably be a separate document posted to Google Classroom with a couple other examples if you wanted more to look at or write down. Okay, but this is the last example we'll go through in the video. It says for the real valued functions, f of x equals x minus 4 divided by x plus 1, and g of x equals 2x plus 5, find the composition f of g and specify its domain using interval notation. So again, this is an f of g of x. And so we want to use the f function, but we're going to substitute the g of x function in for our input of f. So if you want to start by just looking at what you started with, f of x, use the outside function here. Okay, f of x is equal to x minus 4 over x minus 1. If I want f of g of x, anywhere that there is an x, I'm going to substitute in a g of x. So I'm going to have g of x minus 4 over g of x minus 1. Now, it also, our problem tells us what g of x is equal to. So what I can do is do one more substitution. Take 2x plus 5 and substitute it in for the g of x's. So 2x plus 5 minus 4 over 2x plus 5 minus 1. Do a quick simplification here, so simplify it. 2x plus 5 minus 4. 5 minus 4 is a 1, so we're going to get a 2x plus 1 on the top. 2x plus 5 minus 1. 5 minus 1 is 4, so we get 2x plus 4. This is what our function is. You don't have to do anything further. You don't have to try to divide these out. It's not possible to make it any simpler. That is where you would stop. Okay. Now, this time, the domain isn't going to be that we have to set something greater than or equal to 0. This goes back to what you did in 5.1. 5.1, remember when we had a division statement like this? I guess the original like this, you had to say the domain, you'd have to look at that denominator, make sure it does not equal 0. That's what we're running into right here. We want to make sure that this denominator does not equal 0. So for our domain, we're going to say 2x plus 4 cannot equal 0. So we want to figure out what value of x is not going to be included because it causes our denominator to be a 0. So if you solve this, subtract 4 over, we get 2x cannot equal -4, x cannot equal -2. Now, what this is saying is that every single x value works except -2. So when we write the domain in interval notation, this is where we're going to have a union because our gap is at -2. Every number before -2 works, every number after -2 works, but -2 doesn't. So here's how we're going to write that. We're going to start off with a parentheses. We're going to go from -infinity to a -2, and we're going to put a parentheses. Because -2 is not included, but remember, every number up to -2 does work. Then we're going to start back up at -2 with another parenthesis. So again, it's saying every number right after -2 works, but -2 doesn't. So -2 to a positive infinity. So if you ever have one with a gap where you're just getting one number that's not going to work, you're going to write it as a union like this. If it's just something like this where you're just making sure that the numbers stay positive, you're going to have just one interval that would look like this. Okay, this stuff can get difficult, so take your time, ask for help from others around you. If you need to look at examples on Alex. But again, do your best and work hard. Have a good day. Thank you. Bye.